Well, here we are with slope-intercept form. This is probably the most famous form of a line. Y equals mx plus b, where m is the slope and b stands for the y-intercept. Now, last lecture, the last series of videos on graphs of equations, we talked about how to find x and y intercepts because they're important. And so sometimes there's advantage to having this slope-intercept form. So we want to, and the most important advantage to slope-intercept form is it's probably, I still think point-slope form you can graph just as easily as you can with slope-intercept form. But slope-intercept form is really how we learn to graph these lines. So we're going to graph a line whose equation is y equals 2/3 x plus 2. Y equals 2/3 x plus 2. All right, so let's graph this line. So first let me set up my graph. So just like we talked about last time, we want to make sure that we're labeling our x and y axis, and we need a scale. So I'm just going to go up by ones here in the y direction and in the x direction. Best practice would be to fill in the rest of these as well. And in the negative direction as well. When we get to trigonometry, I'm going to insist that you fill out the entire thing. Otherwise, you're going to lose track of what you're doing. But for now, if you just had this one and this one, that would be fine. So to graph this in slope-intercept form, the 2 stands for the y-intercept. So the y-intercept, I can read right off of this equation. It's 0, 2. The slope, I can read right off of this equation. It's 2/3. So I'm going to start at the y-intercept, and from there I'm going to count the slope. If the slope is 2/3 and slope is the change in y over the change in x, that's why we say rise over run, the change in the y is 2. So that means I'm going to go from this point, I'm going to go up 2 for every 3 I go to the right. And I'm going to go up 2, 3 to the right. Now, up is a positive move, to the right is a positive move. So I'm going up 2 to the right 3 from each point to get to the next point. Now, this is something very important. This graph that I drew is finite. It's not that big. It barely, it almost fills up the screen, but it's not that big. The graph, however, that I'm graphing, the line that I'm graphing, goes on forever. Like forever. It's infinite. It goes on forever. So when you're graphing these things, just extend them to the edges of the finite graph. Give them the respect of extending them all the way to the edges of the finite graph you're given, especially since they're infinite. So a downward move, so -2 over -3 is still a positive 2/3, but we can see that a negative vertical move would be down, so down 2, and a negative horizontal move would be to the left 3. So that would bring us here. Okay, let me just, I don't want that point marked, okay. So down 2 to the left 3 brings me here, and down 2 to the left 3 brings me here, and down 2 to the left 3 brings me here, and I've reached the edge of my graph, so I'm satisfied. And then we're going to do our best to connect all of these with a nice straight line. This is better on a piece of paper if you have a ruler. I have the special tool. And then if you want to indicate the infinite nature of this line using the arrows, that's fine, but that doesn't substitute doing something like, oh, it's got a slope of 2/3 and it goes through 2. Just doing like a line that's that big. Let's say this were a 3 instead. I don't want to see this, okay? that doesn't really describe the line well enough because we don't know, is it actually going to hit this point here? If you make it that small, like there's just so much variability that could happen with a line that's that small. So extend it all the way to the edge. There you have it. So there's your graph in slope-intercept form, and that's really the best. Slope-intercept is best known for the graphing features. But I also want to talk about the graphs of vertical and horizontal lines. Now, people always mess these up. An equation of a horizontal line is y equals some number. In this case, k is some number, and that number specifically is the y coordinate of that point that the horizontal line goes through. Now, most people think that a horizontal line should be x because x is horizontal. But if you think about graphing a horizontal line on a coordinate plane, here's my coordinate plane, here's the x and y axis. A horizontal line, if we think about it, the y coordinate of all of the points that make up this line, the y coordinates of all these points are the same. So y is equal to the same number the whole time. Y is equal to a constant, whereas x can be any number you want. Likewise, for a vertical line, the x-coordinate of every single one of these points that make up this line is exactly the same. It's a constant. X is equal to some number. That number is the number that is the x-coordinate of every single point that's on that line. And so since x is constant, y is the thing that's changing, the equation is x equals a constant. We don't care what y equals. No matter what y equals, x is equal to this number. So let's go ahead and graph these equations. Y equals 2, x equals 4. I want you to pause and graph these on your own. The next page on the printout, if you printed out the notes, is a graph, or maybe you have graph paper. All right, so let's go ahead and graph these. We have y equals 2, x equals 4. I'm just going to write them down before I forget. So again, I'm going to set up my coordinate plane. I'm going to graph both of these on the same coordinate plane. Sorry if that makes me lazy. But we're going to set up our coordinate plane. Scale in both directions, 1 and 1. All right, so let's start with y equals 2. Y equals 2. So a y coordinate of 2. Y is equal to 2. Y is also equal to 2 over here, and it's equal to 2 over here, and it's equal to 2 here, and it's equal to 2 here, and 2 here. So we're actually covering all the places where y is equal to 2. That gives me a horizontal line. As opposed to where x equals 4 right here, and here, and here, and there, and down here, x is still equal to 4. So for every single point where x could equal 4, that gives me a vertical line. Does that make sense? I hope it does. I wish I could be with you guys in person to see your feedback here, but all right, moving on. The general form of a linear equation. Why don't we save this for the next video? I'll see you in that video.